In this video, we discuss learning outcome number 1, which is all about computing 4 measures of center. Specifically, we're going to look at the mean, the median, the mode, and the mid-range for given data sets, and we're going to familiarize ourselves with the properties of these measures of center. So first of all, a measure of center is just a value at the center or middle of a data set. And if you're saying, what do you mean by center? That's a very good question. Different measures of center measure that center value in different ways. So we're going to have 4 different measures of center. The first is called the mean, or the arithmetic mean. It looks like arithmetic mean, but we say arithmetic when it's an adjective. It's the arithmetic mean. It's the sum of the data values divided by the number of values in the data set. So if you've ever computed your average exam score in a class, you were actually calculating the arithmetic mean, or the mean of that data set. Then we have the median. This is the middle value when the original data values are all arranged in order. So you literally put them on a list, and if there are an odd number of them, you pick the number in the middle. If there are an even number of values, you pick the 2 numbers in the middle, and you calculate the mean of those 2 numbers in the middle, and that's the median. Half of the values are above the median, half of the values are below the median. And then we have the mode. This is a great measure of center, especially with categorical data. This is the value that occurs with the greatest frequency. Now, if there are multiple values that all occur with the same frequency, sorry, I got lost for a second in my thoughts. If you have, let's say, 2 values that both occur with a frequency of 5, and 5 is the most number of times any data value appears in the data set, then you can have more than one mode. You can even have 2 modes, we call that bimodal. You can have multiple modes, we call that, I think, multimodal. And if all of the values are unique, so there's no value that appears more than one time, then we say that the data set has no mode. But the value that occurs the greatest number of times with the greatest frequency, that's called the mode of the data set. And then the mid-range just comes from taking the mean of the maximum value and the minimum value in the data set. So you take the max value, you add the minimum value, and you divide by 2. And that's called the mid-range. So first we're going to talk about the mean, or the arithmetic mean. The mean is the sum of all of the values divided by the number of values in your data set. So here are some properties. Means are nice because they vary less than other measures of center. So if you have a population and you keep drawing, let's say, like 20 values from that sample, and then you calculate the mean every single time you draw 20. So you draw 20 and you calculate a sample mean, and then you draw 20 more and you calculate a different sample mean, and you draw 20 more and you calculate a sample mean again. All of those means are going to be very close to each other. So that's what they're talking about here when they say means vary less than other measures of center. The other measures of center that we're going to talk about, if we did that repeatedly, we might get very different values, whereas the means would be pretty much the same or close to the same every time. Another quality of the mean is that it uses every data value, because you're adding them all together and then dividing by the number of data values that you have. And then this is very sensitive to outliers. This is something that you want to keep in mind when you're talking about the mean. So if you have one value that's much, much higher than all of the other values, and then you add that and then divide by the total number of values, that's going to, that outlier, if it's much, much higher, is going to shift the mean to be higher as well. That means that that measure of center, that mean value, that number that we're using as the measure of center, might not be as representative of the center of that data set, because that outlier was pulling it to the high end if it was a high outlier, or if you have a low outlier, that low outlier would pull the mean to the low end if we add that in and then divide by the total number of values. Another way of saying that the mean is sensitive to outliers is to say that the mean is not resistant. And here's the definition of resistant. A statistic, remember, that's just a number that goes with a sample. It characterizes a sample. We say it's resistant if the presence of extreme outliers does not cause it to change very much. So if we can have outliers and the statistic stays relatively stable, we call it resistant. If we include outliers and they change the value of that statistic drastically, meaning that the statistic is sensitive to outliers, then we say it's not resistant. So here is some notation. If it looks like Greek, that's because it is. I've got this Greek letter sigma in the top left-hand corner. It's a Greek letter sigma for sum. Now, usually there's something in front of it, and so this is going to represent the sum of whatever you put in front of it. So it's the sum of something, and this says the sum of a set of data values. And normally if I'm talking about the sum of the data values and I'm using X to represent the values themselves, then you would see the sum of the X's, and we would think of that as the sum of all of the values in our data set. X is usually the variable that we use to represent individual data values. Lowercase n is the number of data values in our sample. Capital N is the number of data values in our population. Now, X bar is the mean of sample values. So if you have some larger population that you're interested in, and then you randomly select n values from that population, and then you calculate their mean. The sample mean is denoted by this, and that X with that line segment above it, that's pronounced X bar, and that is equal to the sum of the X values divided by the total number of X values, which is the same as the sample size, lowercase n. I found this image online, or I saw this image on Facebook years ago, and I thought it was so cute, so I wanted to include it in the slide. Mu is what we use to represent the population mean. It's calculated in pretty much the same way. You take the sum of all of those values and you divide by the size of the list of values that you're looking at. But when we're talking about mu, we're talking about the mean for everyone, for the entire population. X bar is the sample mean, so that's a subset of the population, that subset that we selected. And this mu is the population mean, excuse me. It's the sum of all the X values, all the values for the entire population divided by that capital N, which represents the number of values in the entire population. So we've got this little kitty here. You didn't know he was talking about statistics, but yeah, he's not actually meowing at you. He's talking about population means, apparently. Okay, so now we've got an example. We're asked to find the mean of the first 5 data values or data speeds for Verizon in a particular data set. And they are 38.5, 55.6, 22.4, 14.1, and 21.1. These are all in megabits per second, which can be abbreviated in that way. If I want the mean of those, I just add them together, and I've got 1, 2, 3, 4, 5 values. So n equals 5. We add them together and we divide by 5. And it turns out we get 30.74 megabits per second. That's the sample mean of those 5 data speeds for Verizon. Now this slide is courtesy of Mr. Triola, and I believe that it's probably accurate. He really hates the word average. And again, Mr. Triola is the author of our textbook. The word average is often used for the mean. It is, if you talk about your exam average or your average in the class, you're usually talking about the mean. But it's sometimes used for other measures of center. So whenever somebody's talking about the mean, the median, the mode, or the mid-range, they could theoretically use this word average, although most of the time when someone says average, that we intend to say that they're talking about the sample or the arithmetic mean that we've just discussed. But Mr. Triola hates that. He says it's ambiguous, don't ever use the word average, and you'll see that over and over again in our textbook if you read our text. He says, and this is directly off of his slides, I've just added some highlighting for emphasis. He says the term average is not used by statisticians. The term average is not used by the statistics community or professional journals. So because you're taking a statistics class and we want to be professional, we're not going to use the word average anymore. We're going to use the word mean when we intend to say, we intend to say that we're talking about adding all the values and then dividing by the total number of values in that list. And it's X bar, which is the sample mean, if we're talking about some subset of the population, or it's that mu, which is like well, it is not like it is a Greek letter that represents the population mean. So don't use the word average in this class. We're going to use mean from now on, except when we use Excel. Excel actually uses the word average for the arithmetic mean. Now, the median is the next measure of center. This is the middle value when the original data values are arranged in order. Usually, I like to put them in order from smallest to largest. He says an increasing or decreasing magnitude. Either way is fine. You just want them in order. Sometimes this is denoted by X tilde. It's got that little tilde sign over the X. And here are some properties of the median. This is nice because it's a resistant measure of center. If you add an outlier at the top of the list or you add an outlier at the bottom of the list, even if you add a couple of outliers at the top or the bottom of the list, it really doesn't change that middle value in the list very much. So that means it's not particularly sensitive to outliers. So it's a resistant measure of center. The median does not directly use every data value. It really only uses the middle value in the list or the middle two values if you have an even number of values on your list. Okay, so I've hinted at this. The way you compute the median is you sort the values, you arrange them in order, and then if the sample size is odd, so if there are 15 values on the list, that median would be the middle number on the list after they have been sorted. So we'd ignore the top 7 values and we'd ignore the bottom 7 values, and we'd look at that 8th value, which would be directly in the center of a 15 element list if the sample size n was 15. If the sample size n is even, then you sort all of the values. Let's say there are 20 values in your data set. So you had n equals 20. Then the 10th and the 11th value on your list, after you've arranged them in order, would be averaged, or you would add them together and divide by 2. You would compute the arithmetic mean of those two values in order to find the median value for the sample if your n value is even. Okay, so we've got the same 5 data values from before for those data speeds for Verizon. If we want the median, the first thing we do is we list them in order. So the smallest one is that 14.1, then the next one is 22.4, the next one is 23.1, the one after that is 38.5, and the one after that is 55.6. So you put them on a list, smallest to largest, and then you pick the middle one. So the median of this list of 5 data speeds for Verizon is 23.1 megabits per second. Okay, so now let's say instead of having those 5 data values on the list, we just added one more. Now you've got 6 data values. So you've got 38.5, 55.6, 22.4, 14.1, 23.1, and 24.5. You still have to arrange them in order. So you've got 14.1, then 22.4, and so on. Now you can do this by hand, but I'll also show you how to do this using an Excel spreadsheet in the homework help videos. So we're not going to use Excel in this video, but you can look through the homework help videos and you'll see how to do this in Excel, and it's really easy. There's literally a button that says sort, and then you put smallest to largest, and then it will sort the values for you. You sort the values and then you say n equals 6. So we're going to ignore the first 2, ignore the last 2, and we're going to focus on those 2 in the middle, and then we're going to compute the mean of those 2. So we add them together, and then we divide by 2, and it ends up being 23.8 megabits per second. The mode is the value that occurs with the greatest frequency on your list. Some properties of the mode include this. This can be found with qualitative data. With qualitative data, you can't really calculate that arithmetic mean, that regular mean. If you're talking about, let's just say, hair color, it doesn't make sense to talk about the mean of like 5 brown hair and like 3 blonde hair and 2 red hair. It doesn't make sense at all. But we can talk about the mode. We can talk about the category that has the highest frequency. That is an excellent measure of center for categorical or qualitative data. So that's one of the reasons why we have this as a measure of center and why it's so important. Now, a data set can have no mode, one mode, or multiple modes. Now, this is how you distinguish between those 3 cases, or those, well, 2 of those cases. If there's no data value that's repeated, so all of the data values are unique, there's no mode. Now, it's possible that there's one data value that appears the most number of times, then that would be the mode, and it would just have a single mode. Now, it's also possible that you have 2 data values that occur with the same frequency, and that frequency is the greatest frequency in the data set. So maybe you see the number 12 in your data set 20 times, and you also see the number 15 in your data set 20 times. Well, then both 12 and 15 are modes, and we say that the data set is bimodal. And it's also possible that the data set is multimodal. So maybe the greatest frequency is, a certain amount, and there are several values, more than 2 data values, that have that frequency. Each of those values would be a mode. Okay, so the circles on this one actually give this one away. It says find the mode of these sprint data speeds, also in megabits per second. We've got 0.2, 0.3, 0.3, 0.3, 0.6, 0.6, and 1.2. Well, there are 3 0.3s, there are 2 0.6s, but there are 3 0.3s. I've got 3 of them. And that's the number on this list that occurs with the greatest frequency. So 0.3 is the mode of this data set. It occurs 3 times, whereas 0.2 only occurs once, 1.2 occurs once, and 0.6 occurs twice. So here are some other examples. Let's say we want to find the mode of this data set. You've got 0.3, 0.3, 0.6, 4.0, and 4.0. Well, 0.3 occurs twice, and 4.0 occurs twice, and 0.6 only occurs once. So the highest frequency is twice, and you've got 2 values that occur twice, both the 0.3 and the 4.0. So we've got 2 modes this time, 0.3 and 4.0. In this example, we've got these data speeds, 0.3, 1.1, 2.4, 4.0, and 5.0. None of those are the same. So they all occur with a frequency of 1. So there's actually not a mode in this case because no values are repeated. Now, it happens that if you're dealing with a normal distribution, and that's that distribution that has that bell shape, if we were to look at its histogram, the mean, the median, and the mode are all the same for the normal distribution. So the mean, remember, that's what you get when you take all the data values, you add them together, and you divide by the total number of values on your list. That's the mean. That turns out to be the same as the mode in the case when you have a normal distribution. Now remember, the mode is the data value, that appears with the highest frequency. That's the number, the value in your data set that appears the most number of times. So if you add the numbers together and divide by the total number of values in your data set, and you look for the value that appears the most often, those are going to be the same thing if you're dealing with a normal distribution. And it turns out that that is even the same thing as the median if you're dealing with a normal distribution. And remember what the median is. The median is the value that you get if you sort all of those values in order from smallest to largest, and then you look at the middle value. And if the n is odd, it's just the middle value. And that middle value separates the bottom 50% of the data values on your list from the top 50% of the data values on your list. Or if n is even, you take those 2 middle values, you add them together and divide by 2. That's the median in that case. Still, that median is separating that data set into the bottom half and the top half. all three of those are exactly the same if the distribution is normal. So that's an important quality of normal distributions. So when you talk about measures of center, it's like, yes, these are all three different things, but if the distribution is normal, they actually all give you the center. They all give you the exact same center value for your data set. The fourth and final measure of center that we'll discuss is called the midrange. This is the value halfway between the maximum value and the minimum value in your original data set. So you just take the max and the min, you add them together and divide by 2. It's like you're computing the mean of the maximum value and the minimum value. So here are some properties of this. This is very sensitive to outliers. It's not resistant at all. If the maximum happens to be an outlier or the minimum happens to be an outlier, or they're both outliers, this measure of center is determined by the largest number in the set and the smallest number in the set. So if you change those outliers, if you delete them, or if you include an extra one, something like that, or if an extra one happens to be included in your data set, it's going to change the midrange a lot. So if you keep taking different samples and some of those samples include outliers, the midrange is going to change a lot as you compute from sample to sample. So this is not a very resistant measure of center. One of the benefits of the midrange is that it's very easy to compute. You can look at a data list, sort it in Excel, and it's very clear to see what the minimum and the maximum are. So you just add them together and divide by 2. Most of us could do that in our heads. So that's nice. So midrange is a very easy to compute measure of center. You should be careful about this last one. Sometimes people will confuse the midrange and the median. Sometimes people will say that the midrange is what the median is. So let's just distinguish between the two of those. With the median, that's the value that splits the top half from the bottom half. So half of the data values are below the median and half of the data values are above the median. The midrange is the mean of the maximum and the minimum value. So the midrange is halfway between the maximum and the minimum, but there's no guarantee that that number that's halfway in between the maximum and the minimum leads to half of the data values being above that value and half of them being below. So remember, median splits the top half from the bottom half. The mid-range is halfway in between the max and the min in your data set. So here we're going to calculate the mid-range of those Verizon data speeds again. So we'll look for the minimum value, that's 14.1 megabits per second, and the maximum value is 55.6 megabits per second. Add them together and divide by 2, you get 34.85 megabits per second. We've got some round-off rules for measures of center. When dealing with mean, median, and mid-range, we like to carry one more decimal place than is present in the original set of values. With mode, though, we're actually picking a value from the list, so we just leave the value as is in that case. So let's review our 4 measures of center again. You've got the mean, add all the values together and divide by the total number of values. The median, so you sort the values in a list. If the number of values, that's the sample size n. If that's odd, you just pick the middle number. If it's even, you take the 2 middle numbers and you add them together and divide by 2. And that's the median. It separates the top 50% from the bottom 50%. The mode is the number that occurs, the value in your list that occurs the most often. And if all of the values are unique, there's no mode. If one value occurs more often than the others, you have one mode. If a number of values all occur with that same highest frequency, all of them are modes. And then the mid-range is the mean of the maximum and the minimum of your data set. It splits that range of values that you have. You've got a min over here, a max over here, and the mid-range is halfway in between the minimum and the maximum. But it's not necessarily halfway, or it does not necessarily split the list of data values into the top half and bottom half like the median does. Now the mean, median, and mode can all be calculated using technology. I'm going to show you in other videos, those are the homework help videos, how to use Excel to calculate the mean, median, and mode. I'll show you how to do it using formulas in Excel, and then I'll show you how to do it with some built-in functions in Excel. And then the mid-range, you can also use Excel for. Once you've sorted those values, you just pick out the min and the max and you add them together and divide by 2. And so that's it for our 4 measures of center. And I will see you in the next video, or you will see me in the next video.